Okay, I want to show you how to make factor trees, writing numbers in prime form or prime factorization. And what we'll do is we'll write it out as prime numbers, and then we'll also write it out kind of more efficiently as exponential numbers. And I'll give you several examples so you know what I mean. Okay, so let's just start off easy. Let's start with the number 8, and we want to write the number 8 using only prime numbers. And so one strategy is to first write off or write down a list of some prime numbers, starting with your lowest prime numbers and then working up. And I'm only going to do a couple because we're not going to really go into big numbers here. So the lowest prime number is a 2. Then there's 3, 5, 7, and I know there's more, but I'm going to stop at 7. Okay? So every time we make a factor tree, we're going to start with the lowest prime number that is that we can divide into the number that's given. Now, because 8 is an even number, I know that 2 goes into 8, and it goes into 4 times. So I'm going to draw these branches, and you can think of the 8 as the top of the tree, and then there's going to be a branch coming off in each direction, okay? And so I'm going to put my 2 here and 4 here. So 2 times 4, and you could put a dot in there to represent multiplication. So 2 times 4 is 8. Now, 2 is a prime number, however 4 is not a prime number, so we want to continue with our branches to break down this 4 into prime numbers. And I know that 2 times 2 is 4. So again, I'm going to draw some branches going out in both directions and then write down my prime factors. Now you can see that these numbers on the edge of my branches are the prime numbers. And if I write them down, it's going to look like this. So 8 is made up of these factors, these prime factors, 2 times 2 times 2. And that's true. 2 times 2 is 4, 4 times 2 is 8. Now, if I want to be a little more efficient, I could write these factors in exponential form. Okay, exponential form. That means I'm going to write it with an exponent. Now the base is 2, so that doesn't change, and I'm multiplying 2 to itself 3 times, so it's going to be 2 cubed, or 2 to the 3rd power. Okay, so these numbers here are written in prime factors. Okay, and all I did was changed it into exponential form, but really both ways are going to represent 8. Let's go ahead and do a couple more, just so you kind of get the idea of what I'm talking about when I'm asking you to do these factor trees. Let's say we have the number 20, and I want to find the prime factors. So again, I'm going to start with 2. Okay, I'm going to start with 2. 2 goes into 20 10 times, so 2 times 10. Now 2 is prime, so now I'm going to work my way on this side. This is not prime, so I need to break it down further. 2 goes into 10 5 times. Now 5 is a prime number, so I don't need to go any further. I've found all of my prime numbers. Okay, see, I've got them here. So if I write that out, 20 is made up of 2 times 2 times 5, or if I want to use exponential numbers, I could go 2 squared times 5. Now, we wouldn't necessarily say 5 to the first power. You generally don't do that. You only write the exponent if it's larger than 1. So this would be the exponential form. This would be in prime factor form. Let's do another one. Let's say we have, how about 32? Okay, 2 goes into this, that's an even number. 2 times 16. Again, I could break that up, 2 times 8. And we've already done 8, so let's just go ahead and break that up. Okay, notice we have 5 2's that make up this. So we could write it as 32 has 2 times 2 times 2 times 2 times 2, or 32 as 2 to the 5th power. Okay, so this is in prime form, this is in exponential form, using a prime number as a base. All right, let's do another one that doesn't have 2's in it. Let's say we have the number 35. Okay, now before we had our numbers, I'll write them here. So 2, 3, 5, 7, and so on. 3 doesn't go into 35, but 5 does. So I'm going to start with the 5. 5 times 7 is 35. And you know what? Both of them are prime. So that's my answer. So 35 in prime form is going to be 5 times 7. And notice we're not going to just rewrite it as 5 to the first or 7 to the first. You know, this is the most simplest way to write it. Oops, sorry about that. Let's do one more. Let's do a really big one. Let's take 180. Okay, so again, 2, 3, 5, 7, and it could go on, but I think we'll be okay. This is an even number, so 2 goes into it. 2 goes into 18 9 times, so this is going to be 90. 2 goes into 90 45 times. Now 2 does not go into 45. 3, however, does go into 45 15 times. 3 also goes into 15 5 times. And 5 is prime. So we've got all of those factors here on the ends of our branches. These are our prime numbers that make up 180. So if I rewrite it this way, I'm going to have 2 times 2 times 3 times 3 times 5. And, you know, if I think of it, you know, 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36, 36 times 5, well, 36 times 10 is 360, divide that, that's going to be 180. So, yeah. Now, I could write it in exponential form just to clean it up a little bit. I've got 2 2's, so that's 2 to the 2nd power, 3 to the 2nd power, and then just one old, plain old 5. Anyway, those are some examples. You'll be given a little assignment where you're going to be making some factor trees, and you're going to write it out this way as well as this way if you can. Okay?